So this morning we want to learn about floating point operations, which is otherwise called FLOPS. We know that inner product is of order n and matrix vector multiplication is of order n squared. So how do we get this order? That is what we want to work on this time. Imagine you are given a vector u and a vector v, and you are given a matrix A. So the inner product will be defined as u times v. Remember, u is zero vector and v is the column vector. So by this definition, u times v will give us this expression. And in this expression, we have n times 1, 2, up to n. And in each term, we have a multiplication. So that means we're going to have n multiplications. There will be n multiplications. And between two terms, we have an addition. That means between or among n terms, we're going to have n minus 1 addition. So when you add up all the operations, we have 2n minus 1 flops. Okay, so if n is very large, so this expression behave like n. That's why we say inner product is of order n. Let's look at matrix vector multiplication. It's defined as this: A multiplied by vector V. A is a matrix. So when you multiply these two, and the result should be on the right hand side should be another column. So how do we get that column? That means we take the vector V, we multiply each row of A. So we have this expression. So we're going to have n of this because A is n by n. So we're going to have n rows of this expression. If you look closely, you see that each row is like an inner product. So we have between each term, we have multiplication, and in all we have n times in this row. And between two terms, we have an addition. So that gives us the same flops like inner products, 2n minus 1 flops. And we're going to have n of them. Remember, matrix A has n rows, so we're going to have n of them. So that gives us n times 2n minus 1. So we have this expression. So if n is very large, this expression behave like n squared. So that's where we get the order n squared, and we'll say in matrix vector multiplication is of order n squared. So we're going to stop there today.